we're going to go ahead and go over some of the reteaching moments for our radicals. The first thing that I want to talk about is the perfect square. So these are important because these are the only numbers that can be under a square root that we can take out. So the perfect squares are found by taking 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. So I'm going to go ahead and fill these in. We could continue our list if we needed. So 144 is 12 times 12. So we could do 13 times 13, which would give us 169. Then we could do 14 times 14, which would give us 196. And we could continue until the numbers end, which they never will. So these are, like I said, the only numbers that you can take the square root of. If it isn't a perfect square, then you have to break up that radical. And so the steps are there. The first thing you want to do is find the largest perfect square that you can divide the radicand by. After you do that, you're going to break it down into the multiplication of 2 radicals. You're going to take the square root of the perfect square, and it comes out of the radical. So that's one thing that we notice students are missing. When you do the square root of these numbers on this list, you lose that radical. And then you're going to leave the leftover under the radical symbol. So we're going to put each radical into the simplest radical form. Letter A is 100, radical 100. 100 is a perfect square. It is 10 times 10. And so what that means is our answer is just 10. Okay, 40 is not a perfect square, so I'm going to go ahead and break it up into 2 radicals. One of those needs to be on our list up here. Okay, so 40 would fall right here. So what I'm going to do is I'm going to take 40 and I'm going to divide it by 36. If it gives me a decimal, I'm going to skip it and move to the next one. I'm going to keep dividing until I find one that is a whole number. So for this one, you would keep dividing and it would eventually come out that 4 and 10 make our 40. Now, this is a perfect square, so we're able to remove that from the radical. So the square root of 4 is 2 without a radical, and this other one we're going to keep under the radical, so it's going to stay 10. So our final answer is 2 radical 10. On letter C, we have a negative in front, and so what that negative means is we are going to multiply it by anything that comes out of our radical. So 45 is not a perfect square, so we're going to go ahead and break it up. The perfect square that can go in here is 9, 9 and 5. This is our perfect square. Hopefully it changes. There we go. And so the square root of 9 is 3, and we're going to keep the 5 in the radical. So out in front here, it says that we want to take a negative times 3, which gives us a negative 3, and we keep the radical 5. So that would be our final answer. On letter D, we have a number in front, kind of like we had the negative with C. So this is saying take 4 times anything that comes out of the radical. 200 is not a perfect square, so we're going to go ahead and break that up. We are going to break it up into 102. Okay, remember you can always go and divide by all of the perfect squares to find the one that goes in evenly. This is our perfect square here. The square root of 100 is 10. So in front I have 4 times 10, which makes me a 40, and then I keep the radical 2. The next thing that we're going to talk about is how to add and subtract radicals. So the first thing that you're going to want to do is make sure all radicals are simplified so that you have the perfect squares out of the radical. Okay, then we're going to identify like terms. For our problems with radicals, your like term has to have the same index and the same radicand, that same number under the radical. After we do this, once we know what ones go together, we can combine them by adding or subtracting the coefficients, the numbers in front, and we keep the common radical. So here, radical 7 cannot be broken up. They both have radical 7, and so what that means is we're going to do 8 plus 3, which makes 11, and then we're going to keep the common radical of 7. We don't add the numbers that are under the radical. It stays that 7 that was in common. So on letter B here, I see radical 3's and I see a radical 6. The first thing I want to make sure is that I can't break them up. So there is not a perfect square that goes into 3 or 6, so they are already broken up as far as they can. Now, what this means is we have 2 different radicals in this problem. We can only put radicals together that have the same radical. So that means that my 3's, my radical 3's can go together. And then this radical 6 is just going to be by itself, kind of like with our x squared terms and our x terms. If there was no like term with it, we just kept it in the problem. Okay, so this is telling me I have 1 radical 3 plus 7 minus 4. So 1 plus 7 is 8. Minus 4 gives me 4, and I'm going to keep the radical 3. And then I'm just going to attach this radical 6. There's nothing to put it with, so it just attaches to my answer. All right, if we look at letter C here, I see a radical 6. We already know from the last one I can't break that up, but I can break up 24. So I'm going to keep my 10 radical 6, and I'm going to break up 24. So that's going to break into 4 and 6. I can do the square root of 4. The square root of 4, maybe. Let's try this again. Sometimes my iPad is a little slow. All right, so the square root of 4 makes it 2, so this would become 2 radical 6. So I went ahead and took this, doing it again, so that's okay. So now we have the same radicals, so I can go ahead and do the numbers in front. So 10 minus 2 is 8, and I'm going to keep my radical 6. So my answer would be 8 radical 6. So remember, we can only put them together in adding and subtracting if they have the same radical. So let's look at letter D here. We have an 8 and a 50 under the radical. 8 is one that a lot of students forget. It is able to be broken up. So this would become 5 times radical 4 and radical 2. And then this one, 50, would become radical 25 and radical 2. So I'm going to go ahead. Hopefully my highlighter will work for me here. And I'm going to do those perfect squares. So this would become, really does not like me switching pens here today. 5 times 2 radical 2 plus 2 times 5 radical 2. So I would have 10 radical 2 plus 10 radical 2. So I'm going to add the 10s in front, and I'm going to keep the radical 2. So 20 radical 2. All right. The next concept that we're going to review is how to multiply radicals. So we start, one of the things I want to say is you can simplify them to start if you want. I find it easier to wait to simplify until the end. Okay, so I don't break up any radicals until the end of my problem, and I've already done my multiplication. So we're going to start by multiplying the coefficients. These are the numbers outside. So you multiply them together. Then you multiply the radicands together by putting them together under the radical. And then we simplify if possible. So I always like to repeat outside times outside stays outside. Inside times inside stays inside. Okay, so here on letter A, these are both inside, so I'm just going to multiply them inside. 7 times 3 is 21. We cannot break up 21, so that is as simplified as we can get. Letter B, we have 2 outside numbers and 2 inside numbers, so I'm going to go ahead and multiply the outside and keep on the outside Then I'm going to multiply the inside and keep on the inside. So outside I would have 12, inside I would have 20. Here we can break up radical 20. We're going to break that up into 4 and 5. So now we just do what we did on the first section. So 12 times 2 radical 5. Well, 12 times 2 is 24. So we'd have 24 radical 5. All right, looking at letter C, it's the same idea as what we just did with B. Negative 3 times 2 on the outside, 8 times 2 on the inside. So negative 3 times 2 is negative 6. 8 times 2 is 16. Hopefully you notice that the square root of 16, that's a perfect square. It just becomes 4, so there's no longer a radical with it. So we would have negative 6 times 4, which is negative 24. Okay. Letter D is a little bit trickier. This is telling us to take the square root of 3 times something, times 2 terms. And so we're actually going to distribute this. So I'm going to take radical 3 times 5 radical 3. And then I'm going to take radical 3 times radical 12. Okay, so it kind of creates 2 multiplication problems here. So on the first one, the 5 is outside by itself. There's nothing to multiply it with. And then the 3's are inside, so I'm going to multiply them and keep inside. So 3 times 3 is 9, stays inside. On the second set here, the 3 and 12 are both inside, so I'm going to keep them inside. 3 times 12 is 36. Hopefully you notice again that this 9 and 36 are perfect squares. So I'm going to lose the radical. The square root of 9 is just 3. And the square root of 36 is just 6. So I have 5 times 3, which is 15, minus 6 gives me an answer of 9. All right, 2 more topics. The first thing we're going to do is we're going to look to rationalize the denominator in a fraction. So the first thing is to see if you can simplify any perfect square radicals. You're going to look to see if you can reduce the radicands, if you can divide the numbers that are under the radical. Remember, reducing is dividing by the same number. So if you can divide them both by 2, okay, then you're going to look to multiply the numerator and the denominator by the radical in the denominator, and then you're going to simplify anything that you have left. So in this section, I should have put this up here. Our goal is to not have a radical in the denominator. Okay, we don't care about the radical in the numerator. We just don't want the radical in the denominator. Okay, so the steps to get rid of that, the first one could be looking at perfect squares. The second one could be reducing by dividing by the same number. The third one is then multiplying by the radical in the bottom. And then after you've done that, you're going to simplify. So looking at letter A, neither of these are perfect squares. I can't reduce because they're not in the same location. So I'm going to go ahead and multiply both by the radical that's in the bottom. Okay, now think back to the last section. You're going to take outside times outside, keep outside, inside times inside, keep inside. So on the top, the 3 is outside and the 2 is inside. So they just stay 3 radical 2. On the bottom, radical 2 times radical 2 is radical 4. Well, we can simplify radical 4. The square root of 4 is 2 without a radical. And the top we can't break up. So my final answer is 3 radical 2 over 2. Looking at letter B, there is not a perfect square here. I cannot reduce. I can't divide 3 or 5 by the same numbers. So I'm going to go ahead and multiply by radical 5. On the top, they're both under. So when I multiply 3 times 5, I get 15. And on the bottom, they're both under 5 times 5 is 25. We cannot break up radical 15. There is no perfect square that goes into it, so we're going to keep it that way. And the square root of 25 is 5. So that would be my final answer there. Letter C here, they are not perfect squares, but I could go ahead and divide both of these by 3. So I would get the square root of 1 over the square root of 4. Well, the square root of 1 is just 1. 1 times 1 is 1. And the square root of 4 is 2. So now it allowed me to get rid of that radical on the bottom. Okay. Looking at letter D, neither of them are perfect squares. I cannot reduce, so I'm going to go ahead. On this one, I only have to multiply by radical 3. Okay, so the top would be 7 radical 3. The bottom, that 3 on the outside would stay, and then inside would be 9. So we're going to keep the top. Radical 9 is just 3, so on the bottom I would have 3 times 3. So I would get a final answer of 7 radical 3 over 3 times 3 is 9. So that would be my final answer. All right, and then on to the last section. This is solving equations. So you have 2 types of equations. You have one with a radical, and then you have one with a square. So we're going to look at equations with radicals first. So the first thing we want to do is we want to get the radical by itself. Okay, on this problem, the radical is by itself, but something that it wouldn't be would be something like radical x plus 5 equals 10. Okay, so here on the side with the radical is a plus 5. Okay, on our problem, everything's under the radical, so we're already by itself. So what we're going to do is we're going to go ahead and square both sides of our equation to eliminate our radical sign. So we're going to square this and this. Okay, now what happens is our square allows this radical to go away. And so we're left with x minus 7. And then on the right side it says 3 squared, which is 9. So now we're out of the radical, so I can use my equation solving skills to get x by itself. So I'm going to get rid of minus 7 by plus 7. So 9 plus 7 would be 16. So my final answer would be 16. Okay. Now we're going to look at one that has an x squared in it. So we're going to get the x squared by itself. So here on the side with x squared, we have a plus 1. So I want to go ahead and get rid of that by subtracting 1. So x squared would equal 49. Once we have the x squared by itself, we can go ahead and eliminate the square by taking the square root. So this square root gets rid of the square. So that leaves me with x. And then the square root of 49 is 7. Now, if you notice right here, I put a little note here. When taking the square root, you're going to have 2 solutions. So one is the positive number, like 7, and then you also have a negative 7 for your answer.